Hello students, welcome back to the math class. Today we will continue with the chapter triangles. In our last session we have already discussed the example 1. Today we will continue with example 2. So example 2 says that AB is a line segment and line L is its perpendicular bisector. If a point P lies on L, show that P is equidistant from A and B. So let us discuss the solution. The question says AB is a line segment and line L is its perpendicular bisector. What does it mean by perpendicular bisector? Perpendicular bisector, it is a line which bisects another line at a right angle. That means the line is perpendicular to another line and the line bisects the other line. Let us draw it. As per the question, AB is a line segment and line L bisects it. Okay, this is your line L. This is the line segment AB. L is the perpendicular bisector, that means this angle is 90 degree. L is perpendicular to AB. So I can write L is perpendicular to AB, and the question also says that L meets line segment AB at point C. So this is your point C. So as per the given data, AC is equal to BC. As L is the perpendicular bisector to AB, so C is the midpoint of AB, that is why AC is equal to BC. Fine. Another data given is if a point P lies on L, okay, if a point P lies on L, so that P is equidistant from A and B. Okay. So let us assume a point P on line L. Now let us join point P with point A and B. Okay. So we can clearly see that after joining point P with A and B, okay, we have two triangles, triangle APC and triangle BPC. Fine. So what it says, show that P is equidistant from A and B. So as per our construction, what we have found, that AC is equal to BC, okay, and angle PCB is equal to angle PCA. Why? Because L is perpendicular to AB, that means PC is also perpendicular to AB. That means these two angles are equal, that are right angles. So that is why angle PCB is equal to angle PCA. What other thing is there? PC is a common side for triangle APC and triangle BPC, isn't it? PC is the common side of triangle APC and triangle BPC. So with all this data, we can prove that these two triangles are congruent. Let us do it. So what we have found? AC is equal to BC, that is C is midpoint of AB, then PC, it is our common side, and angle PCA is equal to angle PCB. Why? Because PC is perpendicular to AB, that means both are right angles. So these three things we have found from the given data. Okay. So now we have two sides and an angle, okay, two sides and an angle for these two triangles. Let us see whether these angles which are equal to each other are included angle or not, because after that only we can go for SAS congruency. So let us find it out. We have a side AC, a common side PC and a angle PCA for triangle APC. Okay, so angle PCA is included angle for PC and AC. Same way in triangle BPC, we have BC, side PC and angle PCB which is included angle. That means this angle is made up of these two sides. Okay, so with that we come to the conclusion that triangle PAC is congruent to triangle PBC. Which congruency? SAS congruency. Okay. So what else it says? So that P is equidistant from A and B. Okay. So as these two triangles are congruent to each other, we know that the all other sides and angles, they are also congruent or they are same to each other. That means AP is equal to BP. Okay. We can write CPCT. Okay. Corresponding parts of congruent triangles. Okay. So AP is equal to BP. That means P lies equidistant from A and B. P lies, hence P lies equidistant from A and B. Proved. Okay. So students, now let us construct two triangles whose sides are 4 cm and 5 cm and one of the angles is 50 degree and this angle is not included in between the equal sides. You can see it in your book, the diagrams are given. See, in the first triangle the given sides are of 5 cm and 4 cm, but the angle 50 degree it is not included. That means the angle 50 degree do not have the sides as 4 cm and 5 cm. It has only one side, that is 4 cm. 5 cm is not the side that is of the angle, isn't it? In the same way, in the second diagram, here also two sides are of 5 cm and 4 cm and one of the three angles is 50 degree. Here the two arms of the angle are not of 5 cm and 4 cm. Only one arm is of 5 cm. That means in this case also the angle 50 degree is not an included angle. So in this case we cannot go for SAS congruency, because in SAS congruency the angle should be included. That means the two sides of the triangle should be the two arms of the angle. So both the triangles those are given in your book are not congruent. Okay. So we can have many more examples for angles which have two sides and an angle equal to each other, but the angle is not included. That's why those triangles are not congruent triangles. So what we can see that SAS congruence rule holds, but not ASS or SSA rule. What does it mean? Let us discuss. See, we have two triangles. Okay, let us draw two triangles. Okay. Suppose this side is 5 centimeter and this is 4.5 centimeter. Let us name this triangle as ABC and this as DEF. Okay. Suppose this height is 4.5 centimeter, okay, and this side is 5 centimeter, and this angle is 50 degree and this angle is 50 degree. So, in this case what is happening? This angle is not included. Which is the included angle of this triangle with these two sides? This is the angle that is included angle. Same way, this is the angle which is included angle, but this is not the included angle. So, these two triangles do not hold the congruency of SAS. So, in this case, see, two sides they are equal, one of the angles are also equal. That means we can write it as SSA, side, side and angle. Two sides and one angle are equal. So, SSA, it is going for SSA. So, in case of SSA, the triangles are not congruent. Okay, only triangles are congruent in case of SAS. What happens with ASS? So, this SSA can be written as ASS. That means one of the angle and two sides they are equal, but the angle is not included. So, in case two triangles they have two equal sides and one equal angle, when they will be congruent? If and only if that angle is the included angle of the two equal sides. So, only SAS, congruency is satisfied, okay, not SSA or ASS. Hope you understood this concept. So, students, next let us discuss about another concept of congruency. As your book says, next try to construct the two triangles in which two angles are 60 degree and 45 degree and the side included between these angles is 4 centimeter. What does it mean by included side? We have already discussed about included angle. So, included side is the side which is common for two different angles. Included side is a common arm of two different angles. So, let us draw two triangles. As per the given data, so students, as given in your book, I have constructed two triangles, okay, with the base 4 centimeter and angles 60 degree and 45 degree. So, what is included side? So, in this case, this side is a common arm of angle 45 degree and angle 60 degree. So, this side or the base of the triangle is called the included side of angle 60 degree and angle 45 degree. This happens in case of both the triangles. Both have the base as 4 centimeter, which is included side of angles 60 degree and 45 degree. Okay. So, let us see it practically. Okay. Let us cut out these triangles and place one triangle on the other. What do you observe? See that one triangle covers the other completely. That is, the two triangles are congruent. Repeat this activity with more pairs of triangles. You will observe that equality of two angles and the included side is sufficient for congruence of triangles. This result is the angle side angle criterion for congruence and is written as ASA criterion. That means ASA. angle, included side and angle. So, this gives us ASA criterion for congruency of triangle. Okay? Students, since this result can be proved, it is called a theorem, and to prove it we use the SAS axiom for congruence. So, what does theorem 7.1 says? ASA congruence rule. Two triangles are congruent if two angles on the included side of one triangle are equal to two angles on the included side of the other triangle. Okay? Let us prove it. Dear students, let us name these two triangles as triangle ABC and triangle DEF. Triangle ABC and triangle DEF. Fine. So, we are given two triangles ABC and DF in which angle B is equal to angle E 60 degree and 60 degree. Angle C is equal to angle F. Angle C is equal to angle F 45 degree and 45 degree. And BC is equal to EF. BC is equal to EF, that is 4 centimeter. So, we need to prove that triangle ABC is congruent to triangle DEF. So, these all are your given data. So, to prove triangle ABC is congruent to triangle DEF. We have these three data given, that is angle B is equal to angle E, angle C is equal to angle F and BC is equal to EF. Okay? For proving the congruence of the two triangles, see that three cases arise. What are they? Let us discuss. Let us discuss case 1. So, let AB is equal to DE. What we can take? Let AB is equal to DE. Let AB is equal to DE. Now, what we can observe that AB is equal to D, angle B is equal to angle E and BC is equal to EF. AB is equal to DE given, okay. BC is equal to EF, that is also given, and angle B is equal to angle E, it is also given. So, we have three data, two sides are equal and their included angles are also equal. That means triangle ABC is congruent to triangle DEF as per SAS congruency. Side, angle, side, side, angle, side. Okay? So, these two triangles as per the case 1 are congruent to each other following the SAS congruency. Okay? So, let us discuss case 2. So, as triangle PBC is congruent to triangle DEF, what we can conclude that angle PCB is equal to angle DFE, okay. Angle PCB is equal to angle DFE. Why? CPCT. Fine. Angle PCB is equal to angle DFE. But we are given that, what is given? Angle ACB is equal to angle DFE. It is given that angle ACB is equal to angle DFE. That means angle ACB is equal to, okay, angle PCB. If angle ACB is equal to angle PCB, that means what we can say that AC, which is one of the arms of angle ACB, is equal to PC, which is the arm of angle PCB. That means here A and P has to coincide, isn't it? The points A and P has to coincide. That's why these sides are equal. Okay, these sides are equal. Hence it is proved that A and P are nothing but a single point. They coincide with each other. They coincide with each other. That means as they coincide with each other, BA is equal to ED. BA is equal to ED. So, we can now say that triangle ABC is congruent to triangle DEF. By which congruency? By SAS. By SAS. So, in this way we can prove that these two triangles are congruent by using SAS axiom for case 2. So, let us discuss case 3. So, let us discuss case 3 and let us take AB which is less than DE. Okay? AB less than DE. We can take a point M on DE such that ME is equal to AB. We can take a point on DE, that is M, okay, and AB is equal to ME. Okay, AB is equal to ME. So, ME, fine. So, ME is equal to AB. This is assumed. Okay. Now, we can conclude that AB is equal to DE by repeating the arguments as given in case 2. We can conclude that AB is equal to DE, AB is equal to DE by repeating the arguments that were given in case 2. How can I do? We can join the point M and F, okay, join point M and F to get triangles ABC and triangle MEF, and we can prove triangle ABC congruent to triangle MEF by following such. Why? In this case, AB is equal to ME by construction, BC is equal to EF which is given, and angle B is equal to angle E which is also given. So, B and E, they are included angles. So, triangle ABC is congruent to triangle MEF by SS. Again we can prove that point M and point D coincide with each other. That means ED is equal to AB. ED is equal to AB. Okay, that means the assumption which was taken by us firstly was wrong, and we have proved that ED is equal to AB. That means triangle ABC is congruent to triangle DEF. Okay. So, by taking SAS congruency into consideration and by assuming 3 different cases, we have concluded that 2 triangles are congruent to each other by following ASA congruency. To prove that, we have used the SAS congruency. Okay. So, these 2 triangles are congruent by following the ASA congruency. Fine. You know that the sum of the three angles of a triangle is 180 degree. So, if two pairs of angles are equal, the third pair is also equal, isn't it? In this case, what we have found, angle B and angle C are equal to angle E and angle F respectively. So, angle A and angle D, what happens to them? Angle A is nothing but 180 degree minus sum of angle B plus angle C. Same way, angle D is equal to 180 degree minus angle E plus angle F. That is 180 degree minus 60 degree plus 45 degree. 180 degree minus 60 degree plus 45 degree. So, in the both cases we can come to conclusion that angle A is equal to 180 degree minus 105 degree, angle D is equal to 180 degree minus 105 degree, that is equal to 75 degree in both the cases. So, we have proved that if two pairs of angles are equal, that means the other pair of angles of the congruent triangles are also equal, isn't it? So, two triangles are congruent if any two pairs of angles and one pair of corresponding sides. See, in this case, corresponding side, not included side. Corresponding sides means any of the sides. Okay. Two triangles are congruent if any two pairs of angles and one pair of corresponding sides are equal. We may call it as the AAS congruent rule. Okay. In this case, this is 75 degree, this is 75 degree. We have already proved that these two triangles are congruent by ASA congruency, and we have also seen that the other pair of the angles are also equal. So, we can say these two triangles are congruent by following AAS congruency as well. That means two pair of angles and a corresponding side. Okay. Two pairs of angles are equal and a pair of corresponding sides are also equal. So, with this we have come to the form of AAS congruence rule. Now, let us perform the following activity. Draw triangles with angle 40 degree, 50 degree and 90 degree. How many such triangles can you draw? In fact, you can draw as many triangles as you want with different lengths of sides. So, students, as given in your book, you can see there are 4 triangles. Okay. They look similar actually, isn't it? They look similar, but they have similar angles only. They are not similar triangles. They have similar angles, but the sides are of different lengths. So, we cannot say that these triangles are congruent. Okay. So, though we have 3 angles equal to each other, we cannot conclude that the triangles are congruent to each other. That means the angle is not one of the rule of congruency. Okay. So, if 3 angles of 2 triangles are equal to each other, we cannot say that the triangles are congruent to each other. So, angle is not the rule of congruency. Fine. Students, this much is for today. In this class, we have covered the concept of angle side angle congruency and angle congruency, and we have also concluded that angle congruency and side congruency are not acceptable to prove the congruency of triangle. Okay? We have gone through some examples. In our next class, we will go through some more concepts of the chapter triangle. Fine. Till then, revise everything that you have learned today. Keep smiling. Keep enjoying life. Take care of yourself. Thank you.